Welcome to the last section of Chapter 11. We are going to talk about the distance formula and the midpoint formula. First, we're going to start with distance. So we're going to find the distance between two ordered pairs, -4, 5, and 3, -1. This cache is being awesome and labeling our 2 points as x1, y1, and x2 and y2. Now that just means we're just labeling, saying this is the first point, this is point number 2, okay? So let's go ahead and we're going to put the 2 points on the graph here, and we're going to show you how we can use the Pythagorean theorem to solve the distance here. So we're going to plot our 2 ordered pairs on our grid. So we have point -4, 5, and then our other ordered pair is 3, -1. So what we're trying to do is we're trying to figure out how far apart those 2 points are. So we want to know how far this line segment is. Well, since we have a slanted line, we can't really count. It doesn't really go through the boxes. So what we're going to do is we're going to try and make this into a right triangle. So we're going to go ahead and make this into a right triangle. And now we can use the Pythagorean theorem. We can just count our side lengths as 6, and the other one is going to be 7. And then we're looking for side C there. So we'll just plug this into the Pythagorean theorem. $85. Gosh, we are having a difficult time today. It has been such a Monday for us. The weather's so bad. My goodness. I think if Miss Cash ever wants a new job, that, you know, an artist would be it. I mean, that is just a beautiful photograph. So we get c squared is equal to 85. So when we square root that, we're going to go ahead and get that the square root of 85 is our length of c. Oh no, we'll just leave it as the square root of 85. We would first check and see if we would simplify that, and we cannot. If you wanted to actually figure out what the square root of 85 was on a calculator, you could, but we don't need to. It should be somewhere between 9 and 10. There is another way to do this, and that is using the distance formula. And before we show you the distance formula, we're just going to go ahead and plug it in and show you how that would work. What we're going to do is we're going to subtract the 2 x values, square them. We're going to subtract the 2 y values, square them, and then we're going to take the square root of the whole thing. So we'll just show you how that looks, and then we'll have you write down the distance formula. So we're subtracting our y values, squaring them. We're subtracting our x values, squaring them. And then we'll take the square root of that. And we see that we end up getting the same numbers, 36 plus 49, which will give us a square root of 85. All right, let's go ahead and write down what our distance formula is. The distance formula is going to be the square root, and then we're going to subtract our 2 y coordinates, y2 minus y1, we'll square that, plus x2 minus x1, and square them. And then we take the square root of that whole quantity. This is helpful because we're not going to always have graph paper to use to do the quadratic, or I'm sorry, the Pythagorean theorem. So let's look at number 1. We're going to first label our points, x1, y1.
Horrible time today.
And x2, y2. So we'll label our points and we're going to plug it into our formula. One minus 4 squared plus 2 minus 6 squared.
I need the following students to come to the
Oh my
office.
goodness, we're going to have to pause here.
Cassidy Chiloha.
Hopefully if your name was on the announcements, you went to the office. Continuing on. So we square both of them, and then we have 9 plus 16. We take the square root of that. So the square root of 25 will give us 5. So if we were to draw those 2 points, or excuse me, plot those 2 points on a grid and then find the distance between them, it would be 5 units apart. So we're going to go ahead and do this for number 2 as well. We're going to label x1, y1, x2, y2, and then we're just going to go ahead and plug into our formula. A lot of times people will make a mistake of not plugging the right things in with the right things. You have to be sure you're subtracting the y quantities from each other and the x quantities from each other. And we can avoid this by always labeling x coordinates and y coordinates. We get the square root of 8. We should, of course, simplify that. So we're thinking what perfect square goes in, and that would be 4 and 2. So this will simplify to 2 root 2. And the reason we're just going to leave it like this is we always want exact answers, not rounded answers. Okay, so this is the distance formula. The other thing we're going to talk about is the midpoint formula, which is just like it sounds. We're just going to find the midpoint between 2 points. So what we're doing is we will add the 2 points together, x1 plus x2, and then we divide by 2, and add our 2 y coordinates together and divide by 2. And I kind of think of this as taking the average of the x's and the average of the y's. Okay? So our answer will be an ordered pair since we're looking for a point. Okay? So we can plug in our formula. We can label x1, y1, x2, y2. So we'll go ahead and we'll add them together, -4 plus 3 and 0 plus -1, or 0 minus 1. And then we will have -1 over 2, and again, -1 over 2. That's it. If you want to switch them to decimals, you go right ahead. There's nothing to reduce, so we'll just go ahead and leave that as our answer. Last one. We'll go ahead and we will label x1, y1, x2, y2. And then we'll plug into our formula, -1 plus 2 over 2, and 0 plus -3 over 2. So our midpoint will be 1/2 and -3/2, or -1.5. So that's going to go ahead and be our answer, our ordered pair. We'll see you tomorrow.